All right, we are reducing fractions. So, as I dig around looking for pens. So when I am reducing fractions, first of all, this is a big nasty fraction. This is an addition-subtraction problem over an addition-subtraction problem, which means I cannot reduce right now. So don't think that you can reduce these y squareds. You cannot. And I can't reduce those y's either. Okay? But what I can do is change my numerator into a multiplication problem and turn my denominator into a multiplication problem and then reduce. So for the numerator, I'm going to factor. I need two numbers that multiply to 25. That when I add them together, I get 10. So that's going to give me a y plus 5 times a y plus 5. Okay? So that is a perfect square trinomial because its factors are itself times itself. Okay? So let's go to the bottom. I need two numbers that multiply to 30 that will add up to 11. So that's going to be 5 and 6. So I end up with y plus 5 times y plus 6. Now, this is a multiplication over a multiplication. So now I can reduce numbers that divide out by themselves. So y plus 5 divided by y plus 5 is 1. So that's gone, which means my answer for this problem is y plus 5 over y plus 6. You cannot reduce the y's. For instance, if I put in a 2 right now, then 2 plus 5 would be 7, and 2 plus 6 would be 8. So I'd end up with 7/8. Okay? So an addition problem over an addition problem, we can't reduce. So we change it into factors so that we can reduce. So let's do this one. This is more exciting. So I am going to rewrite my numerator after I factor it. I'm having problems speaking because I forgot how. All right, so just looking at your numerator, this has a lead coefficient that's not 1, so I'm going to use the AC method. So I'm going to multiply first times last. So I'm going to rewrite this numerator down here so you can see what I'm doing. Okay, so 2x squared times negative 4 is a negative 8x squared. Then I'm usually too lazy to write the x squared. And then I need two numbers that multiply to negative 8, so your signs are different, that add up to positive 7. So I could use a 1x and an 8x, or a 2x and a 4x. Well, your larger number will take this sign. So my smaller number will take these signs. So 8x's minus 1x is 7x's. So that's the pair that I want. So this becomes a 2x squared. I'm going to trash my 7x and put a positive 8x minus a 1x minus 4. You could leave it as a negative x plus 8x, but I just chose to put it in that order because I can. You'll get the same answer I do. So look at your first two, what's common? I can pull out a 2 and an x, and that leaves me with an x plus 4. So look at your last two. I'm leading off negative, so I'm going to pull out a negative, and nothing else factors out, so I can always factor out a negative 1. And that's going to leave me with a positive x, positive 4. So now tell me what is in parentheses, which is going to be an x plus 4, times what's not in parentheses is 2x minus 1. So my numerator in factored form is x plus 4, 2x minus 1. And now let's do with the denominator. So for the denominator, I'm going to run out of room, but we can do this. I'm going to use orange. So I got a 4x squared plus a 2x minus 2. So I'm going to multiply first and last. That gives me a negative 8x squared again. Well, I already have those factors. Okay, so I need two numbers that when I multiply them together, I get a negative 8x squared. But when I subtract, I get a 2. So this time it's going to be that set. Okay, so 4x's minus 2x's matches my middle term. So I have a 4x squared minus a 2x, positive 4x minus 2. I'm going to get a little bit closer because these pens are light. All right, so what's common on my first set? I can pull out a 2x. So I'm going to divide out a 2x, and that's going to leave me with a 2x minus 1. Okay, on this one, I'm leading off positive, so don't pull out a negative. What can I pull out? I can pull out a positive 2, which will leave me with a 2x minus 1. So what is in parentheses is a 2x minus 1. What's not in parentheses is a 2x plus 2. So that is the factored form of your denominator. Good heavens to Betsy. My phone just went off. Give me a second. Let me make it shut up. Okay, so my denominator is now going to become, in orange, 2x minus 1 times 2x plus 2. Hold on, I'm thinking. Okay, sorry. I had to pause because this was all divisible by 2 to start with. And I was like, this whole thing is divisible by 2. I could have divided by 2 to start with, but I didn't, so just keep going. How did I know that it was divisible by 2 to start with? Because this was divisible by 2. That's what was throwing me off for a second. Okay? So now I've got multiplication over multiplication. So now if I've got matching factors, I can reduce them. So I have any number divided by itself is 1. So this now becomes, my numerator is going to be an x plus 4. My denominator is going to be a 2x plus 2. Okay, and you could factor that denominator further if you wanted to be 2 times x plus 1, which that wouldn't reduce anyway, so why bother? All right, so the last example in this video is we're going to multiply this thing. Are you ready? So just like we saw in the past 2 examples, I would like to reduce first. If I can reduce first, then I'm going to have a whole lot easier time multiplying stuff all the way across. So this is addition, subtraction, addition, subtraction, addition, subtraction, addition, subtraction. But the whole picture is I got this fraction times this fraction. So I am going to waddle down here. And I'm going to break this one down, I'm going to break this one down, break this one down, and break this one down. And then I'm just going to write it in one big fat fraction and see what I can reduce. So what I have first is a 10h squared minus a 9h minus 9. So I'm going to factor this one down. Multiply first times last, I get a negative 90h squared. So I need 2 numbers that multiply to negative 90. Your signs are different. That when I subtract, I'll get a negative 9. All right, so as I rip through these factors, I find out that I can get a 6h and a 15h and take the sign of the bigger number. So I just made my little list of factors, okay, and these are the ones that worked. So that gives me a 10h squared, a positive 6h, a negative 15h, and a negative 9. So what's common on my first 2, I can pull out a 2 and an h, and that's going to leave me with a 5h plus 3. What's common on my last 2, I'm leaving off negative, and I can pull out a 3. So divide out a negative 3 will give me a positive 5h and a positive 3. So what is in parentheses is a 5h plus 3. What is not in parentheses is a 2h minus 3. So I'm going to rewrite my numerator as this. So my new numerator is a 5h plus 3 times 2h minus 3. So now, let's do the denominator. So I got a 2h squared. Oh no! I got a 2h squared, a 24, so 2h squared minus 19h plus 24. So I am going to use the AC method. So multiply first and last. I get a 48h squared. So I need 2 numbers that multiply to 48, h squared. Your signs are the same. That will add up to a negative 19. So ripping through, I got a 1 and 48. I got a 2 and 24. I've got a 3 and a 16. So I have a 3h and a 16h, and they will both be negative. So rewriting 2h squared minus 3h minus 16h plus 24. So look at just your first 2. I can factor out an h. That leaves me with a 2h minus 3. Look at your last two. I'm leaving off negative. And I can pull out a negative 8. So that's going to leave me with a positive 2h and a negative 3. So tell me what is in parentheses. Tell me what is not in parentheses. So this denominator up here just turned into 2h minus 3. Wait. 2h minus 3 times h minus 8. Times. So here's the deal. Don't get confused. So I've got this thing times this thing times this thing. So it's just going to turn into a big multiplication problem across the top. I cannot speak. This one I can factor without going off to the side. So two numbers that multiply to 64, your signs are the same, that add up to negative 16 are going to be an h minus 8 times an h minus 8. And normally I would write that as an h minus 8 quantity squared, but I'm not going to. All right, last one. I'm going to take this denominator and factor them down. So a 5h squared minus 37h minus 24. Okay, and then what do I get? I end up with, doing the AC method, 5 times 24 is going to give me 120. So I've got a negative 120 h squared. So two numbers that multiply to a negative 120, my signs are different. That when I subtract, I get a negative 37. And that is going to be let's do positive 3h and negative 40h. So multiply those together, I get this. Subtract them, and I get this. So rewriting, I've got a 5h squared, a positive 3h, a negative 40h, and a minus 24. So looking at your first two, there's no constants that are in common other than 1, but I can pull out an h. So that leaves me with a 5h plus 3. Look at these two. What's common? I'm going to pull out a negative, and I can pull out an 8. So that's going to leave me with a positive 5h and a positive 3. So what is in parentheses? What is not in parentheses? So I'm going to rewrite that as my final denominator. So 5h plus 3 times h minus 8. And I'm just going to start reducing stuff. So if it matches in the top and it matches in the bottom, because this is just 5h plus 3 times 2h minus 3 times h minus 8 times h minus 8. Okay, so I could write this just, in fact, let's do that. I could write this just as one big fat fraction. There we go. That does not say subtraction. That's a big fat fraction. There we go. All right, so I got a 5h plus 3. Do I have one on the bottom? Yes, I do. So he reduces with him. I've got a 2h minus 3. Do I have one on the bottom? Yes, I do. So he's going to go, and he's going to go. Okay? I've got an h minus 8 over an h minus 8. So he's going to go, and he's going to go. And then I've got an h minus 8 over an h minus 8. So he's going to go, and he's going to go. So now the question is, what is your answer? This is a division problem. So any number divided by itself is 1. So that whole thing reduced to 1. So if I had values for h, this whole thing would reduce to 1. And that is the first part of our play posits.